Hello and welcome back to Invitation to Puzzles, where today we have a full deck and missing a few cards puzzle featuring Renban and odd-even cells. Just to go over the rules, there's a link, by the way, if you want to try it down in the description. But to go over the rules, we've got squares, which must contain even digits, so 2, 4, 6, or 8, for example. We'll usually make those blue. So I will make them blue here for you. And then we have circles, which must contain odd digits, like 1, 3, 5, 7, and 9. And by like 1, 3, 5, 7, and 9, I mean exactly 1, 3, 5, 7, and 9 for this puzzle. And then we have these Renban, which need to contain a string of consecutive digits in some order. So in this case, the in some order would mean that I could, for example, do 7, 9, 8. And since that's 7, 8, 9, but sort of jumbled, that's an acceptable way to fill in the Renban. You can never repeat a digit on a Renban, although I think that's not a concern. I guess it's slightly a concern in this puzzle, but not really a concern. All right, so let's get started. Again, there's a link, so if you want to try it, go right ahead. I am going to use coloring as much as I can in this puzzle, shock of shocks. So there are only 4 even digits in the entire Sudoku universe, which are 2, 4, 6, and 8. And therefore, the rest of those digits need to be odd. It's the other 5 digits. And we can actually apply that argument in a few different places, namely actually all of these. Now, one thing that I sort of skipped because I didn't need it there is that Renbans need to have a roughly equal number of odds and evens because it's consecutive digits, and every consecutive pair of digits is... and then my brain went away. Every consecutive pair of digits contains an odd and an even. So, like, 3 evens already told you these two were going to be odd, even without that trick. But this Renban needs to have an odd and an even, and so that's the last even in the universe for this box. So we'll go ahead and odd both of those. Likewise, this needs to contain an even, so that's the last even for the universe, so that's odd. These length 3 Renban definitely need an even. They can't go odd, odd, odd. Likewise, that one needs an even. I do see that in this column, we have all of our odds, so those are even. Oh, I can make the same argument down here. One of these two is even, so these are both odd. These are both odd. Let's see. That's not quite enough. Let's see. I do know that each of these Renban needs to have a 4 and a 6 on it. And I know that because if this Renban did not have a 4 or did not have a 6, then it would have to be either 1, 2, 3, 4, 5, or 5, 6, 7, 8, 9. And both of those contain 3 odd digits, but this Renban has 2 odd digits and 3 evens. Or if you want to think about it this way, the bounding digits of this Renban are even, because remember, that's where we get our not equal number of odds and evens. And so it's not, for example, bounded by 1 or 9. So the 1 and 9 in this box are definitely not on this Renban. They're up here somewhere. But I point that out because it means that within all of these cells, we need to have... So within those cells, we need to have 2 4s and 2 6s. Where are those going? Well, one of them goes in row 3 for each 4 and 6, and the others, therefore, have to go there and there. Because otherwise I'm not getting enough for this Renban. And I can repeat that argument down here within these cells. I need to have 2 sets of 4 and 2 sets of 6, so one of them goes in row 7 and the other goes here. And now I've got some 4, 6 pairs here. So that rules 4, 6 out of there. That makes it go there. And that 4, 6 makes that a 4, 6. So these are the opposite flavors of 2 and 8. Right now that's a 4, 6 because of that 4, 6 pair. That's a 2, 8, and that's a 4, 6 because of that 4, 6 pair. And I can probably catch up my 2/8. So these are my flavors of 2/8, which are definitely different. I can probably also flavor the 4/6s. And that maybe plausibly, possibly, but probably not really did something. But we can pretend that it did something. This box I see has stray 7, or sorry, has 5 odds in it. So these are both even. So this is circly 4/6 and a 2/8 of some description. Oh, this cell, by the way, is even because of the 2 odds on this Renban. I never noticed. I know at least one of these is odd, but they could both be odd as far as I am aware. Okay, so all of these Renbans also contain a 5. I should point out, because they need to bridge the 4 and the 6. So one of those is a 5, one of these is a 5, one of these is a 5, and one of these is a 5. That does a little bit. I think, because I think it means none of these digits can be 5. Because if one of these digits is 5, then we get that digit's a 5 and that digit's a 5. And if you look at what that does, that means that digit's a 5 and that digit's a 5. So we have some sort of complicated X-Wing kind of thing with these 5s. But basically, anytime you see this kind of like right angle thing, you should check and see, does it actually rule 5 out of these? And the answer is yes, it actually rules 5 out of these. Do I really want to write into all of these that they are not 5? Probably not. But I do see something I should do, which is that these are 5 and 7. For sure. Because one of these two is 5. So yeah, again, if these aren't both 5, or sorry, if neither of these is 5, just check. It makes those two 5, which then makes these two 5 right away, which breaks. So one of these is 5, and the other is the 7 for the row. So these are 5, 7, which actually makes these 1, 3, 9. That's not the 3. And that actually makes... Oh, yeah, and that makes that 5. So that's going to actually resolve the whole business with the 5s. Yeah, so that's 5, which makes that 5, which makes that 5. Okay, so now I can't go to 2 here, so X is actually 8 because of this Renban having a 7. So that's a 2, that's a 2. Okay, we can fill in this digit, right? This digit now. This is with a 2, so we need a 3. This is with an 8, so we need a 7. This is with a 2, so we need a 3. Okay, well, this digit can't be a 1 because I would need a 3 on this Renban, and I can't have it. So 3 or 9. Sure is. If it were 9, that would have to be an 8. If it were 3, this would have to be a 2 or a 4. There's a 7 placed right there by Sudoku sneakily in this box. Now that we've done this whole break-in, that was very clever. Okay, so that's a 7 and an even digit, which is in fact an 8. So now that's the 1 and the 9 owing to that given digit. Let's see. One of these is an 8. I don't know that that helps me a stupendous amount right away. One of those is an 8. Let's see. This digit is a naked single because it's odd and it's not 1, 3, 7, or 5. So this is a 9. Which makes this a naked 1 because it's not 3, 5, 7, or 9. That one's a 9. Just is. Yeah, this has a 2 on it with a... Oh, this digit's even just by the row, in fact. So that's odd. And so it's a 2. Which goes with a 3 in this instance, because we know it doesn't go with a 1. So that's the 1. The 1 is in one of these cells, but it can't go on this Renban, because if the 1 goes on the Renban, I definitely also need a 3 on it, but the 3 is claimed for the column already. So that's the 1. So these are a 7, 9, which go with an 8. I can get rid of my condimenting, by the way, I think. I don't think it turned out to be helpful in this particular puzzle. Okay, so there's a 3 in one of those. What is this? This is a 7 or a 9. Let's see. Okay, so these are 1, 3, and 9 as well. That one's not a 3. This one's not a 1 either, actually, because if this was a 1, same thing would happen. I'd need a 3 there, and I can't have it. So that's actually a 3, 9 pair. So we actually know what happens with the 3. So one of these is a 3, and we know it... Right. These aren't 1 either. Sorry. This is an important component of these. These are 5, 7. Okay, so the 3 has to go with a 4 and a 5, and the 9 has to go with an 8 and a 7. So that means that these are 4 and 8 is what we have learned. And so this square is now not 2, 4, or 8, so it is a 6, which actually gives me my 4 6s around the grid. Oh, and I realized this one never became undecorated. Okay, this column still needs a 2 for even digits, but I don't know what I'm doing with that. This is an 8. So these are 2, 4 for whatever that is worth. This is 2 or 4. Oh, sorry, not 2 or 4. This is 2 or 6. I do know that these are 2, 3. Okay, yeah, these are 2, 3. Yeah, that's just the 3 by Sudoku. So that's the 2. And now this is a naked single 6. The column needs the row needs an 8, but it can't go there. In fact, actually, the 8 was just placed in this box if I wanted to do it that way. Makes that a 7 and that a 9 by the row. This is some other sort of 2, 4. These are 3 and 4. And so the question we are, I think, meant to ask is, where does the 4 go in row 5? Because it's just gotten ruled out of being in box 4, and it was ruled out of being in box 5 by these pairs. This is an arrangement we often call a Zach wing, where sort of these 2 pairs rule 4 out of row 5 in these 2 boxes. So the 4 has to go in row 5 in the remaining box, but it can't go there by Sudoku, so it can only go there. Which then makes this digit odd, and as an odd digit, it seems to be a 5 just by the column. That seems to be even because we've now got all the odd digits. And so we can't do 4, 5, 2, so we have to do 4, 5, 6. This 5 also sorts out the 7, the 9, and the 8, and the 5, and the 3, and the 4. 1 and 9, 1 and 3, 9 and 7. Okay, so this is going to be 3 and 4. Okay, let's see. What about here? Okay, one of these is an 8, and it's that one. Let's do it that way. So that's a 5. So 2 and a 4 and a 7. That's the 7. Okay, so that's the 2 and the 4. So that's odd. There's the 2 and the 4. That's a 9. These are 1, 7, 9. So that's the 7, 1, and 9. That's the 2. Okay, there's an 8 for this box. It's a 3. One of these is a 9 in this row. Oh, sorry, no, sorry. There's no odds left in this row. These are just both even. They're 2 and 6 in some order yet to be disclosed. This box needs a 1 as its last odd digit, and it doesn't go there, so it goes there. So now that's even, and that's odd. Okay, so that's a 1 and a 2 and a 6 and a 2 and a 6 and a 5. And I loved that. That was amazing. I really like that. That is one of my favorite FullDeck and Missing puzzles that I have ever done. That was very cool. I liked that all throughout the just so perfectly plotted that everything would work out so nicely the way that everything unraveled. I imagine getting these given digits right was a pain to get this to flow this well. But huge thank you to everyone for watching. Let me know how that went for you. And I'll be back soon. Thanks for watching. Do give the stream a like. Bye for now.